discussion. Today I'll be discussing about the uh, types and application of the nano, micro nanofluidic devices. So we have discussed in previous class we have discussed all the basic things of fundamental things of micro and nanofluidic device. Okay, so what is fluid and the principle of the microfluidics and the fabrication process. Just basic things we have discussed. The detailed fabrication process we'll discuss in the next class. And applications also we have discussed in the brief way and challenges. Now we'll discuss about the types and application of the nano, like micro and nano fluidic devices. So can you just tell me my voice is audible for you or it's not?
It's not clear, sir.
It's like
It's
how it
breaking
is.
in
Like
between.
my voice is slow or some noise is
It's
there,
lagging.
background noise.
The voice is not clear.
Okay, just give me 1 second. I'll change the headphone. Can you tell me now how it is? Is it audible for you? Okay, Nirmala. So just a second. Mhm. So today we'll discuss about the types and applications. And if before going to the today's topic, what I'm discussing today, if you have any doubts regarding the lectures till second week, you can ask me in the text box also, or orally also you can ask. Okay, in what I'll be solve that doubt. If it is not possible, then I'll convey the message to the professional as well. And if you have some detailed description you want, then you can go in the question and answer tab. There you can ask your questions in detail. Okay, is it that clear? Yeah. So we were today we are discussing about the types and applications. So I'll not discuss individually parts. I'll just discuss about the like to both I'll combine and discuss. Okay. So it doesn't like separately discussing of the types and applications are very difficult here. So like I'll try to do that, but it's like both will be having the combination of the types and application. Okay. So if I'll um, describe the types, then research field we can say, and various design also we can say this microfluidic devices we can uh, divide. Okay. So if we are talking about the research field, so there will be various type of the branches where the microfluidic device is has been used and going to be used in future also possibly. So here I'm showing the chemical and material field. There, this is the first one you can see here. This is for the chemical and materials, where they are discussing about the surface modification, pattern repeatability, and surface plasmon resonance kind of thing. They are studying in this chemical and material field. And I'm belonging from this field, so I can correlate it directly to directly in this field. The next one is mechanical and fabrication. So generally, soft lithography, deforming mechanical microchannels, fluid structure interactions are uh, discussed in this like mechanical and fabrication field. Another one is the biological, biomedical, and lab-on-chip applications, where in vitro models they will do in the in cell uh, test they will do, and through chyometry, cytometry, low cost diagnostics they will do here. Okay, in biomimetics they will replicate the biomimic like biological related things, like here is showing that some it's looking like a bamboo sticks they are replicating with us. They are grappling with the artificial microfluidic using the microfluidic device. So artificial vessels can be uh, designed. Lotus leaf effect also can be designed, like lotus leaf will be having the um, hydrophobic surface kind of things can be designed. Swan robotics also can be designed using the microfluidic device. Also, it is very important for the sensors and actuators because it is like quite flexible device you can make using the polymer like a PDMS, or and we can make so many sensors because it is having the continuous flow, and we can restrict that flow, and we can make some kind of we can use for some kind of application direct application for sensors and actuators. So it can be used in the smartphone integration also. Suppose pressure sensors or fingerprint sensors, this kind of things can be done with this kind of microfluidic using this microfluidic device. And miscellaneous like a braille display also can be it can be implemented in the braille displays, and like in this lab on chip and metafluidics also can be done using this. So here I'll discuss this chemical and material one. Just in brief, what is going on here. If we have these two uh, immiscible solvents like water and toluene, will flow this solvents, mixture of solvents through the microfluidic from this side to this side. Okay. Okay. So here what is happening? This water electronic solvent quantity is more and water quantity is less in solvent mixture. So here you see the water bubbles, how it is going from here. And this kind of emulsions can be studied using this microfluidic device. Here the another way is there that water has been used as a medium, there toluene has been mixed, less amount of toluene has been used. And this white bubbles kind of things are uh, flowing through this microfluidic channel. Okay. Here the mechanical and fabrication devices has also can also be fabricated. So where you can see this input reservoirs where we are keeping two different kind of uh, colors like different kind of um, it can be like colored droplets. Okay, so what is happening? It is going through this channel, and here it is reaching this black, dark, dark color fluid. And this is light color fluid, yellowish color fluid, yellow greenish fluid. It is going to here. So here, what is happening? These are acting as a single auxiliary pressure source. So here the thing is like this can when the input reservoir releases the liquid, it will fill here. After that, uh, this pressure source will apply the pressure and it will go as like a pulse. Um, in a pulse, it will go to the another side. Okay, it will also transduce on the other side like a pulse only because both are acting as a single auxiliary pressure source. Then what will happen? These act as a resistors. Resistor, what they will do? They will resist to flow the liquid into the like very fast manner. Then, then this here. So we will clear resistors. Okay. So what is happening after that? This capacitors. Uh, Again, we have discussed this one. It's acting as a single auxiliary pressure source. The capacitor also will be charged, and after that, it will release quickly like electricity. Same thing is happening here also. So again, here again another capacitor is there, and that will go through this acting as a diode, and it is the output. So it is acting as a like a one kind of replication of the electric circuit. Okay, in biological uh, uh, system, it is like a we can say that there will be cancer cells, multiple like parental cancer cells that has different types, basal, luminal, and stem cell-like, and these stem cell-like cells on PDMS substrate has been like treatment. Treatment has been done, and after that, after culture and expand, that will be analysis. This cytometry analysis, uh, like flow cytometry readout, will get to know this which kind of cells, what is the cell size, what is the cell count, what is the morphology, cell cycle phase, DNA content, and other existence, and like what is the like all the cell properties will get to know from here. Okay, cytometry. So this is also very important. Microfluidic device is also very important in the biological side. And for biomimetics, I told that this is like looking at a bamboo, which is like the strength will be like the it will increase, and the bamboo seed same kind of uh, mimicking, like biomimicking can be done. Here you can see the droplets are generated. These are the PLGA droplets. The PLGA is like a uh, lactic and uh, glycolic acid mixture. Okay, so it is a aliphatic uh, polyalcohol which is having the polyesters, and these are very uh, like this kind of micro droplets have been trapped inside the cavity. This you can see here. So these are the micro PLGA microspheres, and which is giving strength to this fiber. Okay. Also, this can be used for this DNA transfection and like you can see here is how the uh, microfluidic device is uh, using here for the uh, sensing the fluorescence or fluorescent. Okay, and for sensors and actuators also can be used. Here you can see that this is kind of a bridge rectifier and have been replicated by this microfluidic devices where input and output have been given. Same has been done for the like a pressure sensor where this here it is showing that where the tension is more tension and because of the compression, and here is um, compre uh, it's like a uh, if you give tension here then the compression will happen here. Okay, and also it can be useful for the particle sensing. uh, Here it is it like a sensor where it's having the PDMS channel, and this is the piezo stage, and having the it contains the back reflector as well. So when the flow is happening from one side to the another side of the nanoparticles, so it will get separated based on the size of the particles. You can see here the small particles, 100 nanometer particles has been separated from the 300 nanometer size nanoparticles using this microfluidic devices. And there are different designs also possible for the micro, like there are different designs also there in microfluidic channels. Here I am showing this 3D printed multi-material wall, okay, and the 3D printed micro mixture, mixture, and output will come here, and 3D printed season pump for pneumatic control, Nafila mixture, microfluidic will like cultures, chip, X mixture, sorting device for living organism based on electric field, and point of care ocular rapid test. Okay, port. So these are the different designs of the microfluidics. And if we'll talk about the applications, so till now the successful applications in the microfluidics, we can say that the group small samples, which is in the which is the area of single cell profiling bioassays, and in the this we can see the current examples of the uh, application is cell single cell analysis, next generation, high throughput genomic sense sequencing, pregnancy test, test strip for monitoring blood glucose, urine test strips. These are the like implemented already. It's going on. This kind of application has been established with the using the microfluidic device. Another is a make material or product, like in material production, design and printing also. So uh, products of cosmetics, lipid nanoparticles for drug delivery go through nozzle or mechanics of droplet formation in droplet based 3D printing applications. Okay, this kind of thing has been already uh, implemented. What are the promising areas of the application in microfluidics? So diagnostics, like time sensitive diagnostic testings. Okay, I think in this we can say that uh, some micro needles, there's some glucose sensors will be there that has been already implemented, and other things also going on in this, like antibiotic susceptibility testings, essential diagnostic tests for low and middle income countries. So it will be low cost, and the sample is required that is also very low, and liquid biopsies uh, for detection of rare biological species, genomic screening for testing efficiency of prescribed medicines, so directly can be adopt the medicine which will be required. using this test, okay, diagnostics. So these are the uh, commercial ventures which are working on these things. Therapeutics for this one is organ on a chip. It's I think it's in a lecture number 6 of Professor Suman Chakraborty. So you can go in there, you can check this one. He has it's discussed in detail this topic. Then antibody discovery, profiling of human gut microbiome for discovery of markers in inflammatory bowel disease. Okay, and other autoimmune autoimmune disease. Just a second. Okay, so these are that commercial ventures are working on these things. Food and consumers. Okay, we were liquid nanoparticles also helping, um, like promising alien this in this microfluidic field. So food and consumers product safety also can be um, implemented, and maybe possible in the few years it can be like commercialized. So detection of the mislabeled misprint foods, okay, and identification of the foodborne bacteria. So for that, this Elegant is working on this, and production and formulation of materials. So synthesis of core cell particles. Suppose magnetic particle we have to synthesize with a drug delivery for the drug delivery. So it can be the magnetic particle can act as a force, and the drug can be act as a cell. And the production of designer particles with controlled shape and composition, production of the active pharmaceutical ingredients, continuous flow synthesis of toxic chemicals, authenticity of perfumes. This can be the promising area in the microfluidic devices. So in future, we can see this kind of things can be implemented. And if you'll see about the applications, we have to think how the microfluidic device works. So here you can see the modular library, how it is having the components. So there will be a valve. So valve act as an on off is like a switch. There will be a pump. So it will pump the fluid mixture. So here's like a Y-shaped mixture, or V-shaped like, mixture. Separator also for like one of the component in the microfluidics. Then droplet generators. So if we have something is coming uh, like continuous flow, if you give if you want to generate the micro droplets or nano droplets, you have to go like the sample you have to uh, pass through this direction. Okay, then gradient generator. Then there will be different kind of connection methods. So Lego connection methods, just like a plug and play kind of things. Tubing connection, fluid connection, okay, O-ring gasket connection, adhesive connection, and plasma connection. So applications we have earlier discussed so many things like biological applications such as cancer cell isolations and PCR, organ on a chip, biomarker research, particle synthesis. Okay, here I am discussing some uh, like more applications regarding the microfluidic devices. Uh, just give me 1 or 2 minutes. Okay, please. Okay, so here this like there are different kind of applications can be possible in the microfluidic devices in a micron or nano level. So you need like very less samples or you like very less energy also you can say to do this kind of work. So first one is like thermodynamic microwatt. Here what is happening? The another like there are two walls and one uh, like a polymer layer. Okay, or in that what is happening? Here fluid is flowing. This is this is a side view, and when you are reading this one, so here the expansion is happening, and if this side is cool liquid is coming, so it will go this side. If it is more heated, then it will be having expansion. Okay, here expansion. So it's showing in the expansion uh, part now in this image. In figure P, it shows that this polymer layer is having the electrodes, and we are applying the bias positive and negative. Because of that, it act as a switch. Here also it is acting, all this are acting as a switch only. So it is based on the heating, it is acting, it is based on the electric field. So when we are applying to opposite it start from both walls, then it is acting as a off. So the fluid won't flow in here. So it will release the it will switch off the electric field, then it will go to the another side and the fluid will flow. Same has same can be done in the PV actuator where the if we'll apply the bias, then actuator will go to the upside and it will um, stop the fluid to flow and it will release the bias. It will just off the cut off the voltage, then it will go back to the normal position and it will allow the fluid. Same can be done on this magnetic using the magnetic electromagnetic microwatt. So where it can be operate it can be operated by the external electric field where this is the permanent magnet and this is like a we can control with the electric field. So when coil is like we are giving the bias to the coil, it will generate this core. In this core, it will generate the magnetic field. Because of that, this it acts as a valve and it will switch off the fluid flow. So this is a hydrogel microwatt where you will just uh, this kind of hydrogels will be there on the channels, and you have to give the more pressure. You have to give more pressure to pass through it, and this like bigger my hydrogel contains more pressure. Like it needs more pressure, so it won't allow the fluid to go this side. Okay, same can be uh, same this wall phenomena can be used mechanically also, like a check valve. So where this elastic uh, strength will be there, uh, that is attached with some kind of wall. When you'll give wire like more pressure, fluid pressure, then it will open. It will having the opposite pressure or you have less pressure, then it will close. Okay. So here we are discussing. We have discussed already uh, the droplet generator. So it is also same kind of a droplet generator only, or you can say that a mixture. Okay. So I think the droplet generator will come later. So this is a macro mixtures. Okay, based on the different principle. So here it is showing that the parallel lamination micro mixture. The another one is the barrier structure micro mixture, and the third one C is showing the staggered herringbone micro mixture. The another kind of thing is also possible droplet micro mixture and electrohydrodynamics micro mixture, then electrokinetic micro mixture. Okay, magnetohydrodynamic dynamic micro mixture. So based on the electric field and like electric field and magnetic field, it will act as a like micro mixture, acoustic micro mixture. If you have here like some suppose you can say that a piezoelectric material is there that can act as a acoustic generator, and because of that, act, this micro based on that, this micro mixture will work. And here this pressure micro mixture, where we are applying this various gradient pressures, and based on that, it will mix. So different micro mixture will be having the different in this different kind of uh, materials, fluids, you can say, we use. Okay, so each will be having, suppose this magnetic hydrodynamic mixture is there, we will use here this which is having the uh, magnetic property in the fluid. For this electrohydrodynamic, it should have the uh, it should be electrically conducting fluid, like that. Okay, then there will be separators, different kind of separators will be there. Here it's like a electrode, we are using the bias, piezoelectric again, we are using the acoustic waves, optical tweezers, it will bind, some chemical reaction will happen, and based on that it will separate um, two fluids mixture, and magnetic separator. So based on the magnetic property, one will be separated, and uh, like here it is uh, expansion is happening, so it can be also separated using this like pitch segment and broaden segment. Okay, clear cut separator, and this micro post array will be there in the DLD separator, that also will be used for the separation. It's like a here in the hydrodynamic filtration separator, the liquid particles, liquid will go with particles, and this hydrodynamic uh, filtration will happen. Uh, in just a second. I'll discuss this one later. Actually, um, Okay, maybe because of channel or something it is separating there, and this kind of separators will be there in the microfluidic devices. And I have discussed previously this droplet generators like here. So these are the droplet generators, and they are having a different mechanism to generate the droplets, different uh, for different applications. So you can see in the ABC, it's showing the scope flow, cross flow, and flow focusing. Okay, and there are different based on the external force. There like external field, there will be uh, this kind of generator, droplet generator will be there, DP, where we use the electric field, magnetic droplet generator, where we use the magnetic field, then acoustic droplet generator, where we use the piezoelectric generator. Okay. Then thermal droplet generator also will be there, laser based on the optical like phonon, because of the phonon also can be uh, micro droplets can be generated, and mechanical droplet generator also will be possible. Okay. So this kind of hydraulic power or compressed air will be used for to generating these micro droplets. Okay. Now the gradient generator. We have discussed here uh, this gradient generator. If you want a dilution of different fragments of the two solutions or two fluids. So here it's showing the example of the blank buffer and stock solution. If we mix this one, these two, so mixture of the both will be having different gradients. This one is the stock solution gradients will be very less. Here it will be having the maybe 50-50, or it's like a both will be having equal. It depends on the uh, geometry of the microfluidic device, and here the gradient of the stock solution will be more compared to the blank shell, and it can be uh, taken to the different applications, or it can be used for the sensing applications. So this is called a three-step gradient generator. Another is a Y-junction gradient generator, where the stock solution uh, and buffer, blend buffer uh, fluid uh, comes to the Y junction, to the Y shape, to the this Y junction, where it will mix and it will go to the another direction, where it will be having the gradients. Here you can see this, the higher gradient will be the stock solution side of the stock solution, and the buffer blank buffer gradient, higher gradient will be this side. Okay, the lower gradient of the stock solution will be this side. The another gradient generator is diffusion based gradient generator, where it's like a some kind of membrane we'll use here, and in the middle of that there will be another channel. When we fluid transduced through this direction, and here the blind buffer, then because of this membranes, it will filter out, and it will go pass out, and it will go to this uh, channel, where it will be having the different gradients. Same. Am I audible to you guys?
Yes, sir.
So here is like a droplet based gradient generator, where like both will be having this kind of Y junction, and because of that it will be having uh, it will be having the mm, both will mix, and it will be having here itself same like this gradient, and we will make this droplets also. So here this whatever the fluid is flowing, with that the other mixed stock solution and buffer mixture of that also will flow. Same can be done here. So we can control the stock solution and buffer, so blind buffer, to get the gradient, different gradient. Okay. So for today, I think this is enough. Uh, we have discussed so many things about the application part, but not in that much detail. But yeah, we have covered so many things in types, different types. Okay, and also we have discussed about the applications in different way. Like based on that, you can choose like which like the field of the research is diversifying in all the directions for the microfluidic device, from the biological to the electronics also. Okay, so we all possible uh, ways it is um, all possible field it is there microfluidic device application. Right? And we have discussed the applications which is implemented already implemented, and promising areas where it can be possible. So uh, suppose this organ on a chip, which is very important hot topic, because all the human body organs will be on the chip, and when the drug will go from either from the lungs to the breathing or oral, how the effect it will um forecast on our body, that can be uh, that analysis can be done easily. But it's very like it's possible in the future. And in microfluidic device, there will be different kind of uh, modules, okay, that we have discussed, and connection methods we have gone through. Now, by this application part, I have already discussed previously. So based on that, you can understand that how many types of microfluidic channels can be designed, and based on the materials, it can be uh, like can be choose can be selected. Okay. Thank you so much. If you have any questions, please ask me. In
Will
this,
these slides be, sir? Will these slides be shared with us?
uh, if you want, actually, I will share this video, okay,
Mhm.
on YouTube, so you can directly go through it.
So maybe know some reference materials or some textbooks which might contain some applications. Or
I didn't get whatever I showed. This slides you want, or something else?
I want to understand if there is some reference material or textbooks that we can refer to with respect to this particular
Okay.
course, or in general about what you have said. Also, like you must have also done some research based on some reference materials,
Yeah,
right? So
yeah,
is it
yeah.
is
These all the things I have taken from the research material only. You can go through the
oh,
reviews. Different reviews will be there. I can also paste some reviews link in this, and I'll share the slides to the uh, what is that Google Drive link. I don't know how you are getting that one, but I am pasting from here to the NPTEL team, and the YouTube video link also I am sending there. Okay.
in the Excel that is there, is it, or in the class? Where are you sending,
Yeah,
sir?
Excel.
Okay. Yeah, yeah. I got the YouTube link of the first one, but the slides I'm not sure if I've seen.
Yeah,
So the slides are
Excel.
in the drive location.
Yeah,
The drive
Drive.
location.
Yeah.
Okay.
In
It's,
Excel sheet, there will be a Drive folder. You
yeah,
can open there.
I think.
You can see that.
Okay.
Okay. Actually, I was about think to go for the questions, MCQ or this kind of thing. But I prefer that I will go for this basic things first, and after that, after completion of the all the aspects, then I'll go for the MCQs. Okay. So next week we'll discuss about the more details for the application and the fabrication part. How the device has been like are fabricated in the laboratory and in the industry. Okay. So next week on Sunday, 3 to 5, we'll discuss about it.
Sure, sir. Thank you.
Yeah. Okay.
Thank you, sir.
Yeah.
Thank you.
Thank you, Neha. Okay.
Thank you, sir.
Yeah.
you.